Hello students, welcome back to your computer science class. Today we are going to do a quick revision of the second chapter, which was encoding schemes and number system. In this chapter, we learned about the different encoding schemes. You all learned about ASCII and ISCII. You all learned about UTF 8, 32, 64. You all learned about bits and bytes. You all also learned about the encoding and cipher, the two words and their meaning. So today we will do a quick revision of the chapter. We know when a key is pressed on the keyboard, it is mapped to a unique code, which is further converted into binary code. So there's a letter which has a decimal value, and that decimal value has a binary number attached to it. This is what you all already know. For example, the hexadecimal value is 0905. The binary value is, this is the binary equivalent. You all have figured you all have learned the meaning of encoding and cipher. And now we know some encoding schemes, that is ASCII, which is American Standard Code. It's a 7-bit code. Then ISCII, which is an 8-bit code. Then we have Unicode. Unicode is also has UTF-8, UTF-16, and UTF-32. This is the Unicode for Devanagari script. We learned about the number systems, and we learned about 4 number systems: binary, decimal, octal, and hexadecimal. And you all know the conversions from each. So you all can convert from binary to hexa, hexa to octal, octal to decimal, decimal to binary. So this is something you all should know. How do you do it? You will give it place values: 2 raised to 0, 2 raised to 1, 2 raised to 2. This number 2 over here indicates the base value of that number system. This number 2 over here indicates the base value. Starts from raised to 0, which will be 1. 2 raised to 1 is 2, 4, 8. And then you will start giving numbers to it. Then we learned about binary number system, which is made of ones and zeros. This was the binary equivalent. We learned about the octal number system, which has the digits from 0 to 7. Hexadecimal number system, which has 0 to 9 and A to F. Then you all learned about the application. Where is the hexadecimal number system applied? It's applied in the main memory, because we have a 16-bit memory address. And for colors on the web page, it has a hexadecimal value to it. If you look at the binary part, it is difficult to remember a color with this, but it's easier to remember like this. Then you saw the conversion between number systems from decimal to binary, how to do it, bottom to up. Then we had done some practices. You can go back to that particular video and re-practice it if you require. If I give you a number, how will you find out the decimal equivalent? You will put the place values, you will add up, and you will get the answer. How do you convert it into octal? You will keep dividing by 8. If I have this number and I tell you this is a hexadecimal number, I want to convert it to decimal, I will do a raised to 0. Correct? A into 16 raised to 0, because this is the 16 is the base of hexadecimal number system. Then we learned about those 3-bit synchronization. So if I have a binary number that I want to convert to octal, octal is a 3-bit number. So I will divide the number into 3 bits starting from the right hand side. And then I will find the binary. I will look at the number as a binary number, and I will give the decimal equivalent of the 3-bit. So let's say this was the number. I divided it into three groups of 3. We divided it into the groups of 3. And then we looked at each group individually. We looked at each group individually and looked at its binary to decimal equivalent. So this would be 5. This would be 2. This would be 6. This would be 2. How did I get it? If you all are still confused about it, you all should definitely consider doing that chapter again. This will be 2 raised to 0, 2 raised to 1, 2 raised to 2. Everywhere. 2 raised to 0, 2 raised to 1, 2 raised to 2, 0, 2 raised to 1, 2 raised to 2, 2 raised to 0, 2 raised to 1, 2 raised to 2. So if you have binary to octal conversion, we divide it into groups and then we look at each group individually. So we don't look at the 0 value because it will be 0. 2 raised to 2 will be 4. 2 raised to 0 will be 1. 4 plus 1 will give me 5. Look here, we don't look at the zeros. We will look at the 1. 2 raised to 1 is 2. Gives me 2. Don't look at the 0. This is 4. 2 raised to 1 is 2. Gives me 6 together. Don't look at the zeros. It will give me 2. Put it together, so it becomes 2625. This is the octal equivalent of this. Understood? Similarly, you will find the hexal equivalent. Octal to binary can also be done in the same manner. So how do you write 1 in binary? You write 0, 0, 1. How do you write 2? You write 0, 1, 0. You have to write all these in 3-bit binary form. Seven, how will we represent? You will say 1, 1, 1, all 3 1. This will be 1, this will be 2, this will be 4. Finally, 4 plus 2 plus 1 is 7. Octal is up to 8, correct? Does it include 8? No. Octal is 0 to 7. 8 doesn't come in octal. All right. So this similarly, you will do your hexadecimal also. Same form over here. You have divided it into groups of 4 instead of 3 because hexadecimal is a 4-bit binary code. Okay. Similarly, you can convert hexadecimal to binary too. So this was the complete second chapter. Now we'll do the third chapter tomorrow. With this, I end today's class. Stay home, stay safe, take care, and keep learning. Thank you.